Hello everyone. Today in our software engineering course, we will deal with the specialized estimations as part of our project planning chapter. So the topics that we will cover is the agile development, web engineering projects, estimation for them. We'll also cover the object-oriented projects, some special type of estimations. Then we will discuss about make-buy decisions, which is also important for any project management. So how does it differ, the agile development estimation? How does it differ from the other projects? So agile development, as you have already understood, it is characterized by several incremental delivery, and each increment is normally for a small duration of 3 to 6 weeks. That is what is recommended. It may be slightly higher, but 3 to 6 weeks is the recommended time period for an increment. And normally the teams are not very large. So what happens is the user requirements in such projects come as user stories or as scenario descriptions or in as use cases. So now what the project manager or the team has to do, they have to ensure that the number of scenarios that are included in the increment that can be completed within the short duration and with the available resources. So this is a constraint for them. The period is a constraint and the resources are always fixed. So when both are fixed, then we have to fit the user stories. The number of user stories that we can take into an increment has to be manipulated so that it fits into it. So the purpose of estimation will be that we have to estimate in such a way that we will be able to take this kind of decision. And also it will become a basis for allocating resource to the schedule of activities within an increment. So how we will run that increment, how we are able to monitor that activities within that increment, that becomes the objective of this estimation, so that we can develop a schedule of activities based on this estimation for whichever are the user stories that we have selected. Now, because it is following the agile principle, so the estimation approach should be informal but disciplined. That will suit the agile principles, and at the same time it should be meaningful for planning the increment, because our one of the aim is planning the increment. So what are the steps that we will have to take? So now in other estimation methods, the scope statement and the requirement description used to be the input to the estimation. So here we have to take the user stories, which are more in the form of a scenario description or as a mini use case, because they are small functionalities. So this is now whatever we have obtained from the customer at the start of the project as part of our communication with them, that will be considered for the estimation of the effort. So what we will do, we will decompose the scenario into functions. There we decompose the complete software into functions or to processes. Here we will take the scenarios and each scenario by scenario, each one, and that scenario we will decompose into functions and tasks. That will be required to develop the function. So whatever are the tasks that is required to complete this function, those things. So we first of all, scenario will be broken to functions and then functions will be broken to the task, the way we did in the process-based estimation. The same way we will take it. There we first did the activities, and within the activities we broke it to tasks, and then we were mapping the functions to it. Whatever is there in our architecture, the functions we were mapping it. But here we are not doing a huge architectural effort. The design is very small, as you know. In the agile method, the design is kept small and simple. So we don't have architecture and design. So what we will do, we will take the scenario one by one and then break it into, first we will break it into functions because the functionality has to be satisfied, and then the functions will be broken to tasks. So it is the other way we are doing. and estimate the effort required for each task by using past project data. So these tasks are very small level, low level tasks. So now this are so small that any experience of the senior developers is good enough for estimating the effort. Otherwise, if it is slightly higher, then we can use the past project data or any empirical method where we are using the function of the size to determine the effort. That kind of function can be applied like the COCOMO, and we can determine. We can take the basic COCOMO and we can determine. Otherwise, we can determine the size of the scenario using the function point. So if we cannot, if we find it difficult to break it, then we can take the scenario itself and we can try to determine the size of the scenario by using a function point. The scenario will now become like a software to us, a software project to us, the scope. So each scenario scope we will take and we determine the FP, or otherwise similar size metrics, which is the object point or feature point, or even the LOC if we can do it. And then this will be used to convert it into effort by using some of the historical productivity data. So either we will do it directly by taking the function and the task, directly we will convert it into, directly estimate the effort, or we will use the size and productivity method. But only difference is we are taking each scenario to estimate the size. So estimates of these smaller tasks are then summed up to get the effort of the scenario. So if we are doing it task wise, so from here we will come to this point. So this estimates that we have got, this is simply sum up. And in the case of scenario, we are making LOC and converting. So the scenario selected for an increment are then added. Suppose we have got three scenarios in one increment or 5 scenarios in one increment. So we have got the estimate for each of those 5. So then we will sum it up and we will get the effort of the increment. Now this effort is our final effort for the increment, which will be used for the planning activities such as scheduling, resourcing, and risk analysis. So this effort we will convert into our schedule, activity schedule, because we have the tasks, and also we will assign the resources and determine the cost, and then to do the risk analysis and all other associated plans, whatever is important for the agile increment. Because in agile increment we always keep the high level technical work and also the management work to the minimum. We try to give more detail attention to the low level design and the construction, so that there will be more quality into whatever we are delivering. Now we go to the web engineering projects. So there we considered the characteristics of the agile project, which is different from the conventional methods. So now we will look into the web engineering projects. So web engineering projects are another type of projects which are many times done using the agile method. So we can use the decomposition as we have done in the agile estimate and sizing of each small tasks, or by using the FP method and then using the productivity method that we discussed in the previous slide. So any web engineering project, we can follow the agile estimation method that we have discussed now. Otherwise, if we are using the FP method, then we can also do the FP information variable. So directly a web engineering project, we can consider the whole of the web engineering project and we can decompose it into the information variables like we did in the function point. But only difference will be that these information variables will be modified to suit for the web application project characteristics. So we will have the similar 5 information variables that we used in our function point analysis. The one is input, then output, then your tables. This was, if you remember, this was internal logical files. And then we had the external interfaces, and then we had the queries. So how we will modify it? Let us look at it. So now the inputs, now they become each input screen and the maintenance screen. So we may be having some direct data input screen that is given by the user. which is normally developed in Java or in CGI or any other Microsoft .NET or anything. And also we will have some maintenance screen which is meant for the administrative part of the web app, and some of the administrative tasks that we have to do, operations we have to do. So there will be some maintenance screen, and also for the upkeep of the system, the web application. Or we can also think of tab, because when people use notebooks, they don't say they say instead of screen they say tab. So these are the that is what we will have to count, how many input screens we have at the part of the inputs and how many maintenance screens we have. Then in the output, there will be static web pages which are only containing some information but no variables. Then we will be having dynamic web page. So there will be dynamic web scripts which are getting populated. Data is getting populated, or variable information is getting populated in the dynamic web page, which are normally written by ASP, JSP, DHTML, dynamic HTML. So we write scripts. So those scripts, how many such scripts we have to write? And these are developed normally by HTML, and these are DHTML. And reports. Reports are also another part of the output, which include both web-based or any other report that is used for the administrative purpose. So there will be some web-based reports, or there may be some normal reports which will be saved or will be reprinted. Then we come to the tables, or in other words, the logical files. These are logical tables in the databases, but we can also, because we are using XML, many times we are using XML objects to store the data inside the web applications. So those XML structures or objects that is used to store the data, those also will have to be considered when we are counting the tables or the logical files. Then we have the interfaces, which are again, these are logical files with unique record format, which are either getting into the system boundary from outside, or they are being sent out from the system boundary, because interfaces are those interfaces that we have with external sources. So this unique record format, whatever are we getting and the going out, so those things we will count. Then we have the queries. They are externally published data or a message oriented interface. So when we have web applications, sometimes we are publishing, sometimes we are pushing data somewhere, or we have a we have a subscribe kind of publishing type of architecture. Then we will be publishing data, or we may have a message oriented interface. That means we are sending some message. We have these listeners and things like that. So we might be sending a message which a listener will listen, it will accept. So those are the queries. So we are going to do those kind of things. We count those kind of things in the queries. So all these DCOM external interfaces, we have to communications, any communications between the objects or elements of the web app, those things we have to see in the queries. Then having understood this, so now once we have done this, what we will do, we will count this, we will count this, we will count this. Then we will use a complexity factor, and we will give some weights as we have done in the FP. And based on the practice of web apps, either we can use the same thing that we are using for the FP, the average, the simple average and complex weighted factors, or we can modify it based on our own practice of our organization. And then we can determine the some weighted sum. And if we want to use some indirect factors, influencing factors, those factors we can take and arrive at the effort as we had done for the FP method. Now what we will have to do is, suppose we don't want to do that method, is there any other method which is totally specifically meant for the web engineering project? So there are some suggestion by Mendy's, she's a researcher, so her team. to estimate by collecting measures associated with the application called as predictor variables. So she calls it predictor variables. What are these predictor variables? They are page count, media count, function counts, and web page character. And for these things, page, media, and function, they are web page characteristics, that is page complexity, linking complexity, graphics complexity. I'm sure those of you who are in the practice of developing web applications, you must be able to very well understand, because these are the specific characteristics that happens. We have to do it for the designing of the web page, or for the construction of the web page. Similarly, for the media, for every media, we have to see the characteristics, media type, duration, etc. For the functions, we have to see the code length, the reuse of the code. So from this, we will get some information about these three types of predictor variables. These informations can then be used to compute the total project effort, and also the page authoring effort, the media authoring effort, and the scripting effort. So we will do these three things, and by using any empirical development method. So we have got this count. So this counts will be a kind of a size information or a volume information for the web engineering project. And these are very specific variables which are available only for a web engineering project. Now this will be taken as the size, and from this size we will have a function, an empirical function. We can develop by doing a lot of experiments. We can develop an empirical model, which will be effort is equal to a function of the size, where the size is defined in terms of page count, media count, and function count, along with its weighted factors. So that one we can use for determining the effort. So this is a direct method that can be used for the web engineering by taking its own characteristics. But however, there is a lot of shortcomings, because this is mostly done in the research field, by taking very small amount of observations, just to prove the hypothesis or the methodology. But it is not put in practice. So to make it work in the practical field, it needs this method needs to be used more often, so that lot of data can be generated and it can be proved. So that is why it is little risky, and when you use this, you have to use it with a less amount of confidence. But definitely people can start using it, and they can develop their own, or at least it can be used to get a feel of the estimation and tally it with the previous FP method estimation, and see whether it is giving a very different figure, or it is giving the same figure. So we can validate our FP method estimations by using this kind of predictor variable of size calculation. Now we will look into the object-oriented projects. So this is slightly different. Actually, object-oriented projects can be done by any of the methods, and there is absolutely no difficulty. Any of the conventional approaches we can do: size, productivity, process-based, empirical. But Lorange and Kidd have given a lot of metrics for the object-oriented projects, and using those metrics, they have suggested some alternate approach. So again, this is a specialized effort where we can take this alternate approach, and we can verify we are just getting an alternate method, so we can verify our estimates whether they are correct or not. See, always we are very focused on the estimate. It is a very important fact. If the estimates go wrong, then your plan goes wrong, everything goes wrong with the project. So that is why a lot of emphasis is given for the estimates in any software project. So let's see the steps here. This is the steps I have written down. Develop estimate using effort decomposition used for conventional such as FP analysis. So this is the first step, we have done it. Then you will develop use cases using object-oriented analysis modeling. So when we are doing the object-oriented analysis, so we will take the scope, and we will do a little bit of our high-level use case modeling in the O analysis. and that we will develop and determine a count taking into consideration that use case may change. So we will put in some uncertainty also, uncertainty factor whenever we do the count. Then determine key classes from the analysis model called as analysis classes. So again, we will go into the key class diagrams. Whatever classes we have been able to identify in our analysis, requirement analysis model, that we will take. And from that, we will determine the key classes. That means mostly the entity classes. Then the categorize the type of interface for application, such as graphical user interface, complex, simple ones, complex ones, text-based. So all the user interface we will check, and then we will determine a multiplier for their support classes. That means for each key class will be associated with some of this interface class, because these are the boundary classes of our system. And to get the data from the external entity to the key classes, we need this boundary classes. So they are the support classes. So that's why we have to take this and we have to create the multiplier, how many support classes. So now multiply this factor with the key classes to get the number of support classes. Then compute the total number of classes. So here, as you can see, we are basically looking at the complexity of the user interface, and we are trying to calculate a weight which is getting multiplied and getting the support class. Then compute the total number of classes by adding the key class and its support class. Now, what you do, now you try to determine the effort of this class. If we have to develop these classes, then how much time it will take. So we can take an average number of work units, say, so for example, approximately 15 to 20% days per class. So by taking such a rate, you can get the effort required for all the classes. This 15 to 20 is just an approximate figure, but you can determine your actual figure by looking at your past projects. Or you can possibly find it in some of the standards, productivity standards. You can look into the standard productivity metrics tables, which is provided by IFPOG and many other organizations, and you can see how much it is. So you can take that. So by this, using this productivity factor, percentage per class, you can determine what is the effort for all the classes. Now you have FP method. You have the use case, which you have not done anything, but you can also take the use case count, and then similarly you can take the average number of work units per use case obtained from past projects, and you can determine the effort. So you can determine the effort from the use case. You can determine the effort from the by counting the classes and the support classes, key classes and the support classes, and also by taking the conventional FP method. Now you have to compare the three methods and reconcile the effort estimate determined from class count and those determined from use cases, and then compare it with your conventional FP analysis. So now we have almost exhausted the major estimation methods which are popularly used. In the last two lessons also we were discussing about estimation methods. So now we will come to another area that is called make buy decision. A project manager has, or a software team, many times have to do a make buy decision. What is make buy? Make means you build the software, everything of the software you have to build. Buy means can be buy something, either fully buy or partially buy. So in one of the other estimation classes we have talked of this. We have talked of buying software which is purchased or licensed. The commercially off-the-shelf components are available, so we can either buy them fully, own it, or we can buy it over license and use them. Then we can reuse if either a full experience or partial experience software components are available with us in our organization, then or with somebody else, some other third party, we can acquire it, and we can then modify and integrate it to meet our specific needs. So this is a reuse kind of thing. And then, or we may be having our library for reuse. Otherwise, what we can do, software may be custom built by an outside contractor. So we will only create the specifications. That means I'm thinking that I am the customer now. So I will only make the specification and give it to some software organization who will build it. So there is a contract. Or even if it is a software organization can also give a subcontract to some other smaller organization. So that is also possible. That also happens. So there is always a decision to be made whether we have to fully make it, or fully buy it, or reuse it, or contract it. And when you do the contract, you can also do some partial contracts. So the acquisition of software are defined by the criticality of the software to be purchased and the end cost. So two things are there when you want to buy something. When you want to make a purchasing decision or acquisition decision, then two things are important. How much is the cost I will have to expend, and second is if I have to purchase, will it meet my delivery date? Because I have a schedule to be given. So if I purchase and integrate it, then can I meet the delivery date? How soon can I get this material? Whether if I give contract or I get the license or anything. So in some cases, we can get some low cost software and that is less expensive. And then because it is less expensive, or even so, a lot of the open source software, they're almost free of cost, but there is no documentation for it. And so we don't know how it is written. So we have to actually debug the code and do a lot of experiment to integrate it. So this is one option when we do the acquisition. We can extend those software. The other is that if you want to go for some expensive software products, or you want to go for contracting, then some guideline can be used. So what are those guidelines? Develop a specification for the function and the performance of the desired software. So whatever is the software you want to buy from external vendor, first you create the specification of the function. Okay. And then you estimate the internal cost to develop and required delivery date. So suppose you think that your organization is going to develop that. So now take that specification and use any of the estimation methods and determine how much will be the effort and the cost, and when how fast you can deliver it, because your required delivery date will depend on your business requirement. So then what you can do, you can select a few candidate applications that best meet the specifications, because it is easy to say that I will do it, but you have to search and find the right kind of applications which will have a good match with your specification, because you are trying to buy it. And then you can do something, because you are fully buying it, so then it needs to have a very good match with your specification. Otherwise, you can see some reusable software components that will assist in constructing the required application. So these are both are acquisition cost. And then you develop a comparison matrix that represents a head-to-head comparison. That means for each head, what is the cost you will get, and also you can also determine when it is expected that you can get it, because your delivery date is also important. Your cost is important, delivery date is also important. So comparison of these key functions you can do for each of these heads, and evaluate each software package or component based on past product quality vendor. So this is their cost and delivery date comparison. Also, you can, in this same matrix, you can also add things like what is the product quality that you received when you last bought it, and what is the vendor support. And also for quality, there may be some information elsewhere, you can check that. What is the support that the vendor is providing? That is also important to know whether your software will live for some time. And what is the product direction, where it is going? What is the reputation of the vendor, the company from which you will buy? And like that, many more qualitative information about those components or the software package or the company from which you will buy it. Those things you have to take into consideration, not only the cost and the delivery time you can get, but also this. So you have to create a table kind of thing or a matrix to note down all these things so that you can do a good comparison. You can also contact other users who are using that, or nowadays you have got all these systems, web-based applications where people start giving opinions. So you can look into those opinions or to some other software websites. You can see the comments that people have given by using such kind of software, such kind of reusable software package or component. So all these things will help you in making a decision whether you should go for the full buying, or you should go for buying the reusable software components, or you will be building it because you have already got the cost to develop. So in the final analysis, the make buy decision is made based on the following conditions. So this is what we were discussing. It is already written here. Delivery date be sooner than for internally developed software. And will the cost of acquisition plus the cost of customization be less? Will the cost outside support will the cost of the outside support be less than the cost of internal development and support? So because you will go into a maintenance contract, once you get, after buying, you will also go into a maintenance contract. So both this cost together, whether it is less than your development support, and these conditions can be applied to each of the acquisition option. So we can make that table. And also a decision tree technique can be used. Either we can use it in a tabular form, in a matrix form, and compare it, or we can create a decision tree technique. So in the decision tree, what happens, you put a probability associated to each path in the tree, because you can show these options as alternate paths on the tree, and for each path you can associate a probability of occurrence of that thing, and you can multiply the cost and get the value of that path. So the absolute cost is multiplied with the probability in each path to ascertain the relative value of each decision. So we can see an example here. This is the system. So there are four options: build, reuse, buy, and contract. This is in-house building. We will build it. This is reuse from components library, or some of the our existing work. And then buy means fully buy it, take a COTS, customer commercially available off the shelf software, and do some customization. So there is only minor change. So there can be minor change, there can be major change. So the things that are inside the bracket are the probabilities. As you can see, this is 30% and this is 70%. And contract, if you do contract, then so you have to determine what is the probability that there will be a major change and what is the probability that you will have a minor change. Similarly, for the reuse, the what is the minor change probability and what is the major change probability? It depends on what you are using. So in this particular example, it is shown like that. It is not mandatory that it is when you do your exercise that you will get the same probability. So please remember, this probability is not come from a mathematical formula, but it has been assigned for this particular example. So in this example, to understand, we are seeing that. So if you have a reuse case, in this particular case, minor change is 40% and major change is 60%. And among the major changes, whether how much is simple change and how much is complex change. So major change, so therefore the complex changes are higher, 80%, and simple changes are 20%. And similarly, the build simple and difficult. So after having given this percentage, you have a cost of the build, you have the cost of the reuse, you have cost of the buying and contract. So you can multiply each one with the probability and then get the value of the particular choice. So these are the values of the choices. And if you see whichever is the lowest, you have to go to that. So I have given some explanation for that. Expected value for cost computed along any branch of the decision tree is the expected cost is the path probability of the ith path and the estimated path cost of the ith path, where I is the decision tree path. And so for the build path, they have determined which is 429K. For the expected reuse path, it is 382K. For the expected cost of the buy path, it is 267, and the contract path, it is 410. So these are written here. Okay, so we are adding these two. If you see this, we are adding these two, 70% for this plus 30% for this, because we have two paths. In the buy we have two paths. So 70% we have multiplied with this, and again 30% we have multiplied with this. So we are calculating 400 and 210. This is the cost of 70%. This is the cost of the 30%. So we have taken that. Similarly, cost of this, and cost of this. So here 0.60, and there are two paths here. So we have put a bracket 20%, 80%. This becomes your 60% of the first. So whatever you get here, you have to multiply it by 0.6, and then this. So you get this. So like that, you can get the value of each path. So there are four paths. So there will be four values. And those four values, whichever is the minimum, you can take that decision. So here the buy option is the lowest. So here this buy option, this particular path, minor change plus the major change. So much of minor change and so much of the major change. If you do the reuse, there are three things. So you have to take this multiplied by 0.4, this multiplied by 0.2, again 0.8, and then whatever is the cost that you multiply by 0.6 and then add it. So like that is the calculation we have shown here. So you have been able to make buy decision based on the decision tree. Otherwise, you have to make the same thing in the form of a table or a matrix. So we have come to the end of this lesson. We discussed how increments of a project following agile development can be computed to help in the planning and managing of incremental deliveries. So we went to the agile method, agile development projects, and we discussed how we can do the estimation of the increments, which so that it can be planned and managed. Then we came to the web engineering kind of projects, web apps, where it can be done by the size productivity method or by following the agile method. But what we did is, because they are agile methods, we tried to create another simplified method, slightly modified method of the FP variable. So we actually redefined the FP variables to take care of the characteristics of the web app. So accordingly, we use the size productivity method and we determined. Otherwise, we can also apply the agile method. That is what we discussed, because it is also done based on the agile methods. Then we went to the object-oriented projects that can be estimated using by any conventional method. But then we also saw how Lorenz and Kidd have used either by taking the use case or the class model. So both will give us two different types of effort, and we can then compare and reconcile. Now, since the project or technical managers have to often make a choice between the four options of buying, reusing, contracting, and or building, we have to we saw the make buy decision analysis, and we saw that we can make it using a tabular form, or we can make it using the decision tree. So we have covered all the aspects of the estimation, and even the make buy reuse plan, how to estimate for this reason, and take the proper decision. So we have completed the estimation lessons, and I hope you have understood. You can go through some of the examples that are available or from the books, and that should help you a lot. But please do focus on the estimation, because it is an important part of the planning and the software projects. So thank you all for giving me a patient hearing.